Hello everyone, today I am going to show Mppt solar charger. So this is the circuit design Mppt solar charger. So each components I will be showing. This is for input from the solar. I have used a 10 ampere fuse arduino. Current sensor ACS72010A. This is a buck converter input for the Arduino microcontroller 5 volt. This is a LED indicator for each state of charge. This is buzzer for emergency purpose. This is a filter capacitor for input voltage from the solar. This is 5 volt regulator, from buck to 5 volt regulator, and then 5 volt regulator goes to Arduino microcontroller. This is a MOSFET IR44 and N-channel MOSFET. This MPPT based on 2 pulse, so I have used 2 MOSFETs. So then this is a output terminal from the MPPT. This is cooling fan of 12 volt. This is a charging circuit for this 12 volt lead acid battery. This is a positive and this is negative. I have used a jumper in order to connect. This is a voltage divider circuit. This is for battery and this is for solar. This is LCD 20x4 LCD display. It can display all the parameters. This is a relay I have used for this 2 terminal for conversion of DC to AC. That I will show in part 2. This is part 1. I am making video of part 1. I will show the bridge IC circuit. So this is the bridge IC circuit which I have designed based on IR2104. So I also added a heat sink in order to keep the IC cool, and also I have used externally the 12 volt cooling fan so that it's cool everything, MOSFET as well as IC. This is a charging circuit. I have used a inductor with the capacitors, RLC circuit, and this relay is used for future application for AC to DC conversion. And this buck boost converter, as earlier said, this is used for step down of that voltage, input voltage for this microcontroller, because this system is a self-sustained, so we have to use the voltage from power from the solar panel only. So this is a charging state for a battery. It is having a low charge. When it is a 10%, this will have a 50% charge and this will have a 100%. These two are used for other purpose. This is used for MOSFET is on and off, and this is used for any emergency condition when the battery is very low and even solar panel generate a low voltage. At that time it will glow. So each component I have explained. The schematic diagram and code will be given in the description below. So I will give the specification for battery also. So 12 volt 2.8 ampere. This charger can be suitable for up to 7 ampere hour battery with 12 volt, and the solar panel ranging can be taken up to 12 volt to 20 volt with the 50 watts recommended. So have a closer view of every component. Now I will on the power supply. As per the time being, I don't have a solar panel, so I am using a 12 volt charger. If you have a solar panel, you can use your solar panel to charge your battery very well. Just for demo purpose I have used. This is upgraded version from my previous project. I will share the link of a previous project also. You can get all the details, but this will have the upgraded of everything, so I will be briefing everything in this video. I will show the back side how I circuited. This is I2C LCD display. It's a very simple project. Now I am on the charger. You can see this LED means full half charge is, it is having 80% of charge. It is showing 80% of charge. You see an LCD, solar voltage, battery voltage, PWM signal is 100%, MOSFET is on, load is on. As you can see, relay green, that LED is on, and charging is on condition, and having a more than 10 watts, so it's not showing. And this is the current ampere reading from this sensor, and this is a voltage. This is a solar voltage divider circuit. This is a battery voltage divider circuit. So I will show how that battery is getting charged under 4 mode of condition: on, off, bulk and float. Based on the battery voltage, if it is changes from more than less than 9.5 volt, it will start charging in bulk mode. So LED red is glowing. It starts in the more than 50%. So it will charge in all conditions. So white LED is glowing. If it is more than 80%, the yellow LED is glowing. And if it is more than 15 volt, the buzzer is glowing. In this condition, charger is off, and load is on, and MOSFET is off. Because load is on because the battery voltage is more than the capacity. The operating voltage for load 1 is a maximum 10 volt. So in this way you can design your Mppt charger circuit using a solar panel of 50 watts, 12 volt to 20 volt. That's all about Mppt. Thank you, and please subscribe my channel. Here you will get all the code and circuit design for this project.